Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering a question upon the request of a student from the IGCSE Cambridge book from Oxford by David Rayner. This is the extended book. This is chapter 7, differentiation. Chapter 7 is about graphs, but this is the part about differentiation on page 269, exercise 18, question number 9. So the question here says the curve y equals a half x to the power 4 minus 4x squared minus 3x has a gradient of negative 3 at 3 points. Find the coordinates of these points. Okay, so now, in this question, they're asking us about the gradient of the curve. The gradient of the curve. All right? So whenever you're asked about the gradient of the curve, we have to think about differentiation. Because when you differentiate the function, we get what's called the gradient function, which tells us about the gradient of that function. So differentiating, when you got y, you call it dy dx. This is differentiating y with respect to x. And when you differentiate, you end up by, you differentiate by multiplying the power by the coefficient. So 4 times a half. I'll just write this down as it is, 4 times a half. And then you take 1 from the power. So that 4, you have to take 1 from this power. And then you're going to multiply the power by the coefficient. So it's going to be 2 times 4. It's minus, then 2 times 4. 2 times 4. And then, again, you take 1 from the power. So that 2 is reduced by 1. And the same thing here. There's a power of 1 that's not written. 1 times 3 is 3. So you have to multiply the 3 by the 1. And then take 1 from the power. So you have 1 minus 1 there. And then that's the whole expression. So this line that I just wrote down, it's not necessary for you to write this down. We can go straight from the question to this line here. And, you know, it's basically 4 times a half is 2. And take 1 from the power, you get x to the power of 3. 2 times minus 4 is negative 8. Take 1 from the power, you get the power of 1, which you don't have to write. And then 3 times 1 is 3. Okay, so you end up with minus 3. And x to the power of 0 is 1. Okay, so basically the x term, any x term, just loses the x. If it's just x to the power of 1, just loses the x. And the other terms, when they have a power, you have to multiply the power with the coefficient and take 1 from the power. And if there was a constant, for example, if it was plus 2 at the end, the constant just disappears when you differentiate. Okay, so there we have, this is called the gradient function. This will tell us the gradient of this function for any value of x that we need. Now, where people make a mistake in this type of question is they think, oh, we have to put negative 3 instead of x to find the answer. No, you have to read the question carefully. The question does not say, find the gradient of the curve when x equals negative 3. That would be a different question. This question says, find the point at, or the points at which the gradient of this curve is equal to negative 3. So basically what we have to do is we have to find when dy dx is equal to negative 3. So we have to equate dy dx to negative 3. That's what we have to do. So we have to solve the equation 2x cubed minus 8x minus 3 is equal to negative 3. That's what we have to do. We have to equate the gradient function to negative 3 and solve that equation. Now to solve that equation, it's a cubic equation, all right, which we're not so used to solving. However, it's a cubic equation that will be easy to solve. Why? If I add 3 to both sides to get rid, let's say to get rid of this constant over here, what happens is it becomes nice and friendly for us because this becomes 2x cubed minus 8x. That becomes 0. That becomes 0. So 2x cubed minus 8x equals 0. Now that's something we can solve. We can factorize this and solve it. First of all, let's divide everything by 2 to get rid of the common factor of 2. So you have x cubed minus 4x is equal to 0. Then we can take out the common factor, which is x. So we have x squared minus 4 inside the bracket equals 0. And this will factorize even further. This will be x plus 2 and x minus 2. This is called a difference between two squares. When you factorize x squared minus 4, this is a difference of two squares. Alternatively, what we could have done here is we could have said either x equals 0 or x squared minus 4 equals 0. We could say when two things multiply to give you 0, one of them must be 0. So either x is 0 or x squared minus 4 is 0. In that case, you have x equals 4 or x squared equals 4, I'm sorry. And then when you take the square root of 4, the answer could be either positive or negative 2. In this case, you have these 3 things multiplied together to give you 0. So one of them must be 0. So either it's the x that's 0, or it's the x plus 2 that's 0, or it's the x minus 2 that's equal to 0. Or it's the x minus 2 that's equal to 0. So therefore our solutions are x equals 0, or x equals negative 2, or x equals 2. So x equals 0 and x equals plus or minus 2. Those are the x coordinates of the points at which the gradient is equal to negative 3. Now they're asking us to find the coordinates. We found the x ordinates. We need to find now the y ordinates, then we'll have the coordinates. So let's take the equation where y equals a half x to the power 4 minus 4x squared minus 3x. So we know that y equals, what was it again? I forgot already. A half x to the power 4. A half x to the power 4. And it was minus 4x squared minus 3x. So minus 4x squared and minus 3x. That's the equation for y. So we have to now substitute x equals 0 and x equals negative 2 and x equals positive 2 into this equation to find what y is when x is 0. It's no good substituting this back into the gradient function, because that will just tell us the gradient is negative 3. We know when x equals 0, negative 2 and 2, that's when the gradient is going to be negative 3. We want to find the y values when the gradient is negative 3, and we know these are the x values when the gradient is negative 3, so we just have to substitute them back into the original equation. So when x is 0, y obviously is going to be 0, because all of these are x's. You put 0 in them, they'll become 0. So one of the coordinates is 0, 0. And when x equals negative 2, you have y equals a half times negative 2 to the power 4 minus 4 times negative 2 to the power of 2 minus 3 times negative 2. So y is going to equal, let me just make a bit of space here for this. Whoops, that's the wrong thing that's moving. Okay, so now you have y equals, that's a half times, now negative 2 to the power 4 is going to be a positive because you're raising it to an even power, and 2 to the power 4 is 16. 2 times 2 times 2 times 2 minus, and again you have 4, and this is again going to be positive because you're raising the negative 2 to the positive power. That's going to give you 4, and minus 3 times minus 2 is positive 6. So you'll have y equals a half times 16 is 8 minus 16 plus 6. So that's going to give us 8 plus 16 is 14 minus 16 is negative 2. So that's going to be negative 2, negative 2. When x is negative 2, y is negative 2. If you want to make sure with your calculator, in case you have some doubts, you can do that very easily. You can just stick that in here. You can say a half, and you're going to have in brackets minus 2, negative 2 raised to the power of 4. Oops, what am I doing? Sorry, raised to the power of 4, and then you're going to have minus 4 times negative 2 squared minus 3 times negative 2, and that gives us negative 2 as we found. So that's fine. So when x is negative 2, y is negative 2, and finally when x is equal to 2, y is equal to a half times 2 to the power 4 minus 4 times 2 squared minus 3 times 2. So the first two will be the same. It will be 8 minus 16, but this is going to be negative 6 here, because this is going to be the same as a half times 16 and minus 4 times 4, but this will be minus 6. So that's going to give us 8 minus 6 is 2, and 2 minus 16 is negative 14. Sorry, this is going to be 2, x is 2, and y is negative 16. Is that right? That's going to be 8 minus 16 is minus 8. It's minus 14, sorry. Minus 14. Yeah, because you're going to have minus 22, minus 14. That's right. So 8 minus 16 is going to be minus 8. Minus 8 minus 6 is minus 14. If you want to make sure, you can just put this back into here and just take away the minus from each of these negative 2's. Okay, and you'll end up, as you'll see, with the same answer of negative 14 as we found. So these are the three coordinates where the gradient is equal to negative 3. So we can say the gradient is negative 3, okay, at the points 0, 0, negative 2, and 2, and negative 14. So there's the answer to that question. Okay, so common mistake in this type of question is to replace the x in the gradient function with -3. No, that would be finding the gradient when x is equal to -3. Here they say find the values of x basically when the gradient is equal to -3. So you have to equate the gradient to -3, find the values of x where that is true, and then find the values of y for those same values of x by putting those x values into the original equation, and that's how you get your answer. So I hope that was clear. Thank you for watching. Any other questions you might have from the IGCSE past papers, from the book, you're welcome to ask, and whenever I get time I will upload them. I hope that was understandable for all of you. Thank you for watching, and see you soon. Oh, by the way, sorry, before I go, you will find other questions from this particular chapter of the book and the playlist from chapter 7. You'll find the playlist for that over here. So as I add questions to it, you'll find them adding to the playlist. Other questions you'll find from the topic of differentiation in general, you'll find them in this playlist over here. You can subscribe to my channel by clicking on this link. If you go to the information section, the about section in the channel, or if you're watching from a desktop or a laptop, on the top, on the banner of my video, you'll see a link or links for my A-level and my IGCSE index PDFs, where you can then click to different units that you might be interested in watching. Okay, so that's something that might help you. Thank you for watching, and see you soon.